Hello, let's talk chain rule part 2. In the previous video, you learned how to do the chain rule with trig and with powers. And now we're going to talk about using the chain rule in function notation, which is just as important because you don't always have a formula that you can easily just differentiate using power rules and trig rules and stuff like that. Sometimes you have functions that are just nested functions, composite functions in function notation, and you need to figure out what to do with those. So let's do that. So this is one of those things where I give you a bunch of values where it says g of 5 is negative 3, g prime of 5 is 6, h of 5 is 5, h prime of 5 is negative 2. Find f prime of 5. Okay, now before I get into this, there are definitely times in your mathematics education where we just make crap up. Okay, I'm going to be totally honest. We just make it up. We're like, you know what? Here's a triangle. If the three angles are x, 2x plus 5, and 4x minus 7, find the value of x in all three angles. That's not usually how angles work. But in this case, where it feels like, well, Ms. River, how would I just have a list of values? This is often how the world works. When you go out into the world, there's not a formula for everything. All right, you look at data, you look at data points, and then you decide based on those data points what you can do with it. So I got to be totally honest. When we give you these table problems or just lists of values, and you're thinking, oh, this feels contrived, it's not. That's how things work. This is saying at one point in time, I'm standing at a position that's 3 units to the left of something, and I'm moving at a rate of 6 units per second to the right. Okay, that's like a snapshot in time. That's how data works. All right, so let me get down off my soapbox and then actually, do this thing. It says for each of the following, find f prime. All right, so f is g times h. Well, that's g times h. That's a product rule. So for this, I would know f prime of x is the first times the derivative of the second plus the second times the derivative of the first. So there's my derivative for f. I want to know f prime of 5. Oops. I need to know f prime of 5. So f prime of 5 is going to be g of 5 times h prime of 5 plus h of 5 times g prime of 5. So g of 5 is negative 3, h prime of 5 is negative 2, h of 5 is 5, g prime of 5 is 6. So I have, 6 plus 30 for a grand total of 36. Not a problem. Now I go over to B. B says f of x equals g of h of x. This is not multiplication. This is a composite function. G of h of x, not g times. Make sure you're being very careful about what you see there. So this requires the chain rule. So when I take the derivative, here, f prime of x, I'm going to use the chain rule. Derivative of the outside, keep the inside, times the derivative of the inside. So the derivative of the outer function is g prime. Keep the inside, that's h of x. Derivative of the outside, keep the inside, times the derivative of the inside, h prime of x. Okay, not so bad. So then if I want f prime of 5, I want g prime of h of 5 times h prime of 5, which is going to be g prime of, h of 5 is negative 2 times h prime of 5. Wait, h of 5 was 5. Mrs. Vibber typed in the wrong thing. Whoops, see? There we go. H of 5, I just looked at the wrong number, is 5 times h prime of 5, which is negative 2. So now I need g prime of 5 times negative 2. G prime of 5 is 6. 6 times negative 2 is negative 12. Okay? Okay. So now let's look at C and D. I want you to pause the video, look at C and D, and then come back and then watch me do it and make sure it makes sense. So I want you to pause the video right now. Pause it. And maybe you're back now. So if you paused it and did C and D, okay, now I'm going to go through them, but I'm going to do so a little bit quickly. So C requires the quotient rule, low D high minus high D low, all over low times low. And if I want f prime of 5, I'm not going to write all the 5's in, but I am going to pull all the values. So f prime of 5 is going to be h times g prime, which is 5 times 6, minus g times h prime, which is negative 2, all over h of 5 squared is going to be 25. So let's see. Negative times a negative is going to be a positive. So now I have 30 minus 6, which is 24 25ths. And then when I get to d over here, d requires a chain rule. So the derivative is just like our derivative from b, except I'm going to take the derivative of the outside, keep the inside, times the derivative of the inside. So if I want f prime of 5, I have h prime of g of 5. G of 5 is negative 3 times g prime of 5, which was 6. And now I can't figure it out. And if you remember at the beginning, and I don't know if I said it out loud, if it's not possible, state what additional information is required. I did half of the derivative, but I don't know h prime and negative 3. So if I want to continue with this, I would need to know the rate of change of h at negative 3. All right, now I told you to do C and D. I did not tell you to do E, and maybe you did, and that's great, because I'm going to go over this one too. But this is another chain rule without being a composite of G and H. It's just really a composite function involving G. So if I have G of X cubed, when I go to take the derivative, I'm going to do the power rule as part of the chain rule. So derivative of the outside, keep the inside, times the derivative of the inside. Well, the derivative of the outside is the product rule. So I'm going to bring down the power, reduce it by 1, and then multiply by the derivative of the inside. Well, the derivative of g is g prime. So I need 3 times, so f prime, of 5, would be 3 times g of 5 squared. I don't remember what that is. G of 5 is negative 3 squared, times g prime of 5, which is 6. So let's see. I have 3 times 9 times 6. 3 times 9 is 27. 27 times 6 is like to 27 times 3 times 2, which is 81, 162, I think. Right? 9 times 6 is 54 times 3. Yeah, 162. Yay. Okay, now let's come down here to number 4. A 15-centimeter pendulum moves according to the equation theta equals 0.2 cosine 8t, where theta is the angular displacement from the vertical in radians, and t is the time in seconds. Determine the maximum angular displacement and the rate of change. Whoa, context. That's okay, we can deal with context. So I have a pendulum. All right, is there a pit in the pendulum? Anybody heard of that story, the pit in the pendulum? So here's a pendulum, and it's going back and forth. And that angular displacement that they're talking about is basically figuring out how far from vertical does it get angularly up there. So I have a formula for that. Fine. Determine, oh, my light's turned off. Now I'm in a scary movie here. Determine the maximum angular displacement and the rate of change when t equals 3. So one of the reasons I put this in context is part of the purpose of calculus is to know when to use calculus and when not to use calculus. When do you use just the function, a limit, the derivative, once we get their integrals? So this thing says, determine the maximum angular displacement. Well, what is angular displacement? Well, theta is the angular displacement. So if I want the maximum angular displacement, all I'm really asking for is the highest y value for theta, the highest theta value. So I just really want to know what's the maximum value of the range of this function. Well, the cosine function goes from -1 to 1, and then I'm multiplying that by 0.2. So my maximum theta value is going to be 0.2. That's it. So the work there was really work done in your head figuring out, what do I need to do? Then it says find the rate of change of, there should be a theta in there. Find the rate of change of theta when t equals 3. Well, then I just want the derivative. Okay, fine. So if I want the rate of change of theta, right now I have theta equals 0.2 cosine 8t. And you know what? It's bothering me that I didn't put a 0 in front of that. I like putting a zero in front of a decimal place because it makes the decimal more obvious. All right, so I have theta equals 0.2 cosine 8t. I want the derivative. All right, so my derivative would be d theta dt equals, all right, well, that 0.2 is a coefficient, so it stays where it is. Then the derivative of cosine 8t is going to be a chain rule. So derivative of the outside, the derivative of cosine is negative sine. Keep the inside times the derivative of the inside. And I want to know that rate of change when t equals 3. So I want d theta dt at t equals 3. There's some fun notation for you. If you don't have function notation, you can use a bar to show how you're evaluating it. So I have negative 0.2 times the sine of 24 times 8. And let's see, 0.2 times 8 is going to be 1.6. So negative 1.6 sine 24. And that's just how I'm going to leave it. I'm okay with that. Now, what if I wanted units here? If I wanted units, I have theta units over t units. And theta is in radians and t is in seconds. So that would be radians per second. And there's my answer. All right, last but not least, r is f of g of x and s is g of f of x. And f and g, instead of in table form or equation form, I have in a graph. Fine. They want to know r prime and s prime at 1 and 4 respectively. So let's see if I can find r prime. So r prime is going to be a chain rule. And so I need to take the derivative of the outside, keep the inside, times the derivative of the inside. So r prime of 1 is going to be f prime of g of 1 times g prime of 1. And I'm running out of space here, so I'll just make a little dip. R prime of 1, all right, f prime of g of 1. F prime of g of 1. Well, here's g. And g of 1, I'm going to assume these are units. G of 1 is right here, and that's 1, 2, 3, 4. Times g prime of 1. Well, at 1, the slope of g is 0. Oh, that's nice. F prime of 4 times 0. I don't even need to know what f prime of 4 is. That whole thing's going to be 0. R prime of 1 is 0. Cool. All right, what about s prime of 4? Same thing. Tell you what, pause the video. Pause it. You do it. Then come back. Okay, hopefully you paused it and came back. So if I want s prime of 4, s prime of x is going to be g prime of f of x times f prime of x, derivative of the outside, keep the inside, times the derivative of the inside. So s prime of 4 is g prime of f of 4 times f prime of 4, which is going to be g prime of f of 4. 1, 2, 3, 4. Oh, poop. F of 4 is yucky. I don't want to do that. Well, I guess I'm going to have to times f prime of 4. You know what? I'm going to find f prime of 4 first. F prime of 4. Well, that would be the slope. So I need to know the slope of this line. And I'm going, let's see, over 1, 2, 3, 4, up 1, 2, 3, 4, 5. So my slope is 5/4, which, let's see, that means to get from here to here, I went up 5/4 plus 5/4 again. So f of 4 is 10/4. Ooh, see how I did that? That was tricky. Another way you could have done that is you could have written a y equals equation for that line. But you know what? I didn't need the whole equation, so I didn't find it. So if my slope is 5/4 and I go from 0 up twice, I've gone up 2 5/4, which is 10/4. All right, so I can do that. So then I need g prime of 10/4, which is 5/2 times 5/4. Okay, so g prime of 5/2 is the slope of g at 2.5, which would be the slope of g in that spot. And g's slope in that spot is up 1, right 2. So g prime is 1/2 times 5/4, multiply straight across, is 5/8. Ooh, we end on a fancy one. All right. So that is what we have there. I don't remember what joke I gave you guys last time. Actually, I do. I gave you a really crappy joke about ghosts. Well, I got another crappy joke about ghosts. Okay, so I think it was skeletons last time. So what did the ghost teacher say to her students? What did the ghost teacher say to her students? Hey, did everybody understand this stuff that's on the board? If not, I'll go through it again. Because the ghost can like go through the board. It's a bad one. What can I say? All right, everybody, have a great day. Oh, I got another one. I just thought of it. It's so appropriate. How do I do this? So what is, I don't know. Yeah, never mind. Have a great day, everybody.